first of keeping of phenological records by the ecological community. In fact, phenology became, once again, kind of a dormant science. But in 1976, Aldo Leopold's daughter returned in her retirement to build her retirement home just down the road from the shack, and she resumed keeping phenological records as she had done as a child with her siblings and parents. And after a few years of doing this, Nina observed that the dates that she was recording for these events were, in many respects, earlier than the dates that had been recorded in the 1930s and 1940s. And she published a paper in 1999 that looked at a comparison of the dates in her father's time and the dates in her time, pointing out that many things were occurring earlier and that this seemed to be consistent with climate change, that things were warming up and it would make sense that things were occurring earlier. It was one of the first papers to actually use phenology as a way of understanding the ecological consequences of contemporary climate change. And if you know anything about publishing on climate change, you realize that if you publish a paper on climate change, you are going to be attacked by the climate change deniers. And they tore Nina's paper apart. They pointed out that lots of things had changed since the 1940s. Over this span of time, you could name hundreds of things that were different. Why single out climate change as being responsible for the change in dates when so many other things had changed? And indeed, it sort of set the stage that if you publish a paper on climate change, you just know that you are going to have your paper challenged by climate change deniers. So Nina's paper was based on a simple comparison of the average then and the average now. And it really didn't say a lot about cause and effect between climate and this change. So to some extent, the critics had a point that there were lots of things that had happened. So in any event, Nina's paper was a groundbreaker. Again, the Leopold's breaking new ground. But Nina kept doing this for the rest of her life. Nina died just a year ago and was keeping phenological records up to 2 weeks before she died. She was out there every day, rain or snow, keeping her observations. We're all convinced that's what kept her young at 93 years old, was the passion for keeping these records. Well, she was on to something, of course, because as we know, the climate has warmed in Wisconsin. And if you look at the average spring temperatures for March, April, and May, since 1950, essentially since Leopold's time, Aldo Leopold's time, the spring temperature has increased by 1.7 degrees Fahrenheit at the shack. So Nina was at least on solid ground in pointing out that there had been climate change, and certainly it was perfectly logical to think that many of these events were responding to that increase in spring temperature. She also pointed out, as her father had, that not all species responded the same way. That some of the species were actually occurring early in their events. So of the 55 species that she focused on, 37, 2/3 of the events, did advance. They were now occurring earlier, but 18 events didn't show much change at all from her father's time. They were still occurring on the same date, which again was very consistent with her father's observations that not all species respond the same way. So, for example, if you compare the averages, Columbine, one of our spring plants, back in Aldo Leopold's time, the average was May 19th. In Nina's data, the average was May 9th. A big advance. On the other hand, Dogbane showed hardly any change at all. In Aldo's time, the average was June 20th. In Nina's data, the average was June 18th. The compass plant that Aldo Leopold used as his iconic species for the month of July, because on average it bloomed on July 15th. Well, it would no longer even be appropriate for the essay for July, because now compass plants are blooming the last week in June. Nina made the observation that it appeared that some of the most pronounced advances were among the earliest spring flowers, wildflowers. So things like pastflower and bloodroot are, she thought, among the species that responded the most dramatically. And indeed, both of these species do respond very, very sensitively to temperature. Bloodroot, for example, this year, they bloomed 40 days earlier than the previous all-time record.
Wow.
But in any event, she thought that there was a pattern here. But once again, it was based strictly on a simple comparison of the leaves.